Good morning, students. Last time we had done 1.3. Now we are going to continue with 1.3, sum number 4. And before that, in the last time's PowerPoint presentation, I had given you 3 things to remember. What are the things I had told you to remember? I told you to write it down in your notebook also. Empty set is a subset of every set, and every set is a subset of itself. We are going to use these two over here. Now they are given you one set. A is 1, 3, 2, 7. You have to write the subsets of set A. So we have seen empty set is a subset of every set. So the first one is empty set. The first subset is empty set because empty set is a subset of every set. Next subset will be, I can take one of the elements. One. There is only one element here and that one is fully contained in this. So this set is a subset of this. So let me contain all the 1 elements. 2. Then next I can take 3. And next I can take 7. These are all the subsets of A. Now let me consider two elements. First I'll keep 1 fixed, 1, 3. Next with 1, I can take the next element 2. Then I can take with 1, 7. Then the next subset, I will fix 3. I can take 3, 1, but 3, 1 is already written here. So we don't have to write 3, 1. 3, 2 we can write. Next. And 3, 7. So we have considered all one with 3. Next number is 2. Now 2, 1 is already written here. So that we have considered. 2, 3 is already written here. So what is remaining is 2, 7. Next number is 7. 7, 1 is written here. 7, 3 is written here. And 7, 2 is also written here. So all the elements with 7 have been considered. So all the number of elements 2 set is over. Now let us take 3. 1, 3, 2. Next we can take is 1, 3, 7. Next we can take is 1, 3 is fixed. No? So now we can take 1, 2, 3 is already written. 1, 2, 7 we can take. Next we can take 1, 2, 7. 1, 3, 7 is over. Next we can take 2, 7, 1 is already done. 2, 3, 1 is already then. 7, 1, 3. That is there. So 7, 2, 3. 7, 2, 3. And last, all the 3's are over. Last one is 1, 3, 2, 7 because every set is a subset of itself. So the same elements you can write again. So there are so many subsets. They are asking us only 3. So any 3 of these you can take. Empty set is a subset of every set and every set is a subset of itself. So these two sets will come. Then you can take 1, element. Then you can take 2, element. And then you can take 3, element. And so many subsets we get. Let us go to the next sum. Question number 5, 1. P is the set of all residents of Pune. M is the set of all residents of Madhya Pradesh. I is the set of all residents of Indore. B is the set of all residents of India. H is the set of all residents of Maharashtra. Okay, so they are asking you to write the subset relation between the sets. Last time we had seen what is a subset. If all elements of a set are contained in one set, then it is called a subset. Now here a little bit of knowledge of geography is needed. We know that P is the set of all residents of Pune, M is the set of all residents of Madhya Pradesh, I is the set of all residents of Indore, B is the set of all residents of India, and H is the set of all residents of Maharashtra. Okay, which is contained in which? That is what you have to know. Which place is fully contained in which? Of here, we know that Pune is contained in Maharashtra, isn't it? Pune is situated in Maharashtra. So you can write P is a subset of H. P is fully contained inside H. Next, so this is the first subset. Next subset. Now we know Indore is fully inside Madhya Pradesh. It is fully contained in Madhya Pradesh. So I is a subset of M. And all of these places are fully contained in the biggest set, which is India. Pune is in India, Madhya Pradesh is in India, Indore is in India, Maharashtra is in India. So we can write next, P is a subset of B. I is a subset of B. Then H is a subset of B. All are subsets of B. F. What is remaining now? M. M is Madhya Pradesh is also contained in India. So all are contained in India. So which is the biggest set from all of this? Everything is contained in the biggest set, India. So India is the universal set. They have asked us which set can be considered the universal set. The biggest set is called the universal set. All others are subset of this universal set. So we can say which is that the second question's answer. This is the first question's answer. Second question's answer, you can say B is the universal set. We have finished with the fifth question. Children, whenever you want to write, please pause the video and write down these sums in your notebook. Now sum number 6. Now question number 6 contains two of them, 1 and 2. I'll do the second sum. First sum, the same way you can do for homework. It is asked multiples of 5. You know what is the meaning of multiples? Tables. So you have to write the tables of 5. You list the set and then afterwards solve it. So I am going to the 6th ka second one. First one is for homework. Do it in your notebook. 6. The second sum. P is the set of integers which are multiples of 4. T is the set of all even square numbers. Let us list the set first. What they are asking us, they are asking which set of numbers could be universal set for the set given below. You know what are the set of numbers I have given you in the starting. Which are the different set of numbers? Natural numbers 1, 2, 3, 4 infinite. Whole numbers 0, 1, 2, 3, 4 infinite. Integers, you have to remember the number line. Middle 0, right hand side all positive, left side all negative. And then rational numbers also we have done, P upon Q. Okay, so now let us first list and then see which of these natural, integer, whole, rational are the universal set for this. P is set of integers which are multiples of 4. So list which are the integers which are multiples of 4. Integers. Positive integers, negative integers both will come. 4 ones are 4. 4 twos are 8. 4 threes are 12, 4 fours are 16, all etc. Infinite set. T is set of all even square numbers. So which are the even square numbers? 1 square, 1 is a odd square number. 2 square, 4. 4 is a even square number. Three square, 9. 9 is not a perfect even square. 9 is not even number. 4 square, 16. 5 square, 25 is not. 6 square, 36. 7 square, 49 is not. 8 square, 64. And so on. Again, infinite. Okay. Now, for this, which can be considered the universal set? For P first. Let us take P first. For P, which can be considered as universal set? Can natural numbers be considered for this? Yes, natural numbers contains a set 1, 2, 3, 4, 5, 6, 7, 8. So, natural numbers, these numbers are contained in the natural numbers? No, because it is written set of integers and natural number does not contain negative numbers. So, for this P, integers is a universal set. And for this 4, 16, 36, 64, for this natural number is the universal set. So, you first, for the first one, for set P, set of integers is the universal set. Because that's a number line, positive and negative will both come. For the next one, set T, which is the this thing, natural numbers, set of natural numbers. These comes in natural numbers. This comes in whole numbers also. And integers, set of integers also. Is the universal set. Okay, so first one homework, second one is done for you. Now let us go to the last sum, 7th one. Let all the students of a class be an universal set. Let set A be the students who secure 50% or more marks in maths. Write the complement of set A. 7th question of the last question of this practice set 1.3. Universal set is set of all students of a class. In a class of students, they are considered universal set. A is a set of students who secure 50% or more marks. 50% or more than 50%. So, you have to find A complement. Now, last time we had seen what's a complement. What is the meaning of A complement? Not there in A, but there in the universal set. So, whatever is there in A, we should not write. What is not there in A, that is correct. So, what is there in A? 50% or more. So, what is not there in A? Less than 50 complement. So, set of students opposite of A, securing less than 50%. Have you understood? A is 50% or more. So, A complement will be what is there in A, we should not write, but there in the universal set. So, A it is 50% or more. So, this is less than 50% set of students. So, we have completed with practice set 1.3. Now, let us go to the next topic. Whenever you want to write something, please pause the video and write it down in your notebook. Now we are going to study operation on sets. Just like in mathematics, there are 4 operations: addition, subtraction, multiplication, division. Set has got 2 operations. What are the 2 operations? Union. Second, intersection. So we shall see what are these union and intersection with the help of an example. A is equal to 1, 2, 3. B is equal to 2, 4, 3, 5. Okay, look at these 2 examples. A is equal to 1, 2, 3 and B is equal to 2, 4, 3, 5. Now let us use the first operation, union. Union of 2 sets A and B. From the word union, you know, it means joining. Okay, joining of 2 sets. But whatever is common, you have to write only once. You should not repeat the members in a set. So what is common in A and B? 2 is there here also, here also. 3 is there here also, here also. So you will join the sets A and B. Common you will write only once. So let us join 1, 2, 3. Write all the elements of A. But 2 and 3 are already written, so don't write it again. 4, 5. So what do we mean by union of 2 sets? Set of all elements of A and set of all elements of B, but common only once. The set of all elements of sets A and B, common only once, is called union of 2 sets. Have you understood union? The set of all elements of A, all elements of B, common only once. That is called union of 2 sets. So we are finished with union. Let us go to the next, intersection. Write down this in your notebook. Same example we are going to take for intersection. Okay. Of 2 sets. This is the next operation of sets. What do we mean by intersection? Let us find out. This is the symbol for intersection. When we have learned simple, I had told you. U, ulta of U is intersection. A intersection B. Here you have to write only the common elements. What is common in this A and B? 2, 3. Only 2 and 3 are common. So you can write 2, 3. A intersection B, 2, 3. So only common elements come in the intersection set. So we can say the set of all common elements of the sets A and B is called intersection of set A and B. Copy this. Now in intersection there is a particular type. Okay, so let us study that case of intersection. First case, A is equal to 1, 2, 3. B is equal to 4, 5, 6. Okay, now you tell me what is A intersection B? What is common in A and B? Is there anything common? There are no common elements. It's empty. So if the intersection of two sets, if A intersection, this is A, intersection B is empty, then A and B are called disjoint sets. Write down this also, okay, in your notebook. So what do we mean by disjoint set? When there is no common element, A intersection B is empty, then we call A and B are disjoint sets. Okay, so now you all have studied two operation of sets, union and intersection. Now we are going to take practice set 1.4 does not contain any question on union and intersect, but there are many sums in problem set. So we are going to take that problem set sums now of this type, union and intersection. Hope you have finished writing. Remaining the sums of exercise practice set 1.4 I will be doing afterwards in the next class, because I have taken up union and intersection. So I am doing the sums based on that. Problem set 1. 1.4 I will do afterwards. I am doing union intersection sums. Question number 1, first one. M is equal to 1, 3, 5. N is equal to 2, 4, 6. M intersection N is equal to what? Question mark. Okay, what do we mean by intersection? The common element. What is common here? 1, 3, 5, 2, 4, 6. No common element. So what can you say? It is empty. M intersection N is empty. So which alternative it is? Question number 1 ka 1, the alternative is C. C is empty. The alternative C is giving you the answer empty. Now we go to second and third sum I will be doing afterwards. I told you I am going to do only sums based on union and intersection in this class. So now the fourth sum is about union. So let us write down that. M union N is 1, 2, 3, 4, 5, 6. M is 1, 2, 4. Then which of the following represents set N? N is equal to question mark. Okay. So we have M as 1 to 4. 1 to 4. Now what is missing? 3, 5, 6. So in your N, 3, 5, 6 compulsorily should be there. So where look at the alternatives. First A is 1, 2, 3. That cannot be. But look at alternative B contains 3, 4, 5, 6. The remaining elements 3, 5, 6 and one extra element common. So N can take these values. 3, 4, 5, 6. Then only when you take M union N, no, you will get this. 4 is common, that you write once. So N contains 3, 4, 5, 6. Which alternative is this? Fourth B. Okay. Shall I rub now? No, question number 5, sorry. P is a subset of M. Then which of the following set represents P intersection P union M? You want to find out this. Okay. Now for this, now let us put some numbers and see. Then only we will be able to understand it. Otherwise, we will not able to understand. P is a subset of M. So that means P, suppose let it be 1, 2. If this is a subset of M, means M contains 1 and 2 and one more extra number letters. So now here this condition is correct. P, all elements of P are there in M. So P is a subset of M. Now which set represents P intersection P union M? So first let us find out what is P union M. P union M means join them up. Common only ones 1, 2, 3. P union M is 1, 2, 3. Now you want to find out P intersection P union. P intersection P union M. So you want to find intersection means common. Common in set P and set P union M. So I am marking it. P is this and P union M is this. What is common in both? 1, 2, 1, 2. This 1, 2, 1, 2. So 1, 2 are common. 1 and 2. But this 1, 2 is with set P. So that means P intersection P union M is P. So which alternative is that? Fourth ka fifth sum, which is alternative, which gives you P A. Okay. So now the next union and intersection sum is question number 2, 2. The remaining sums I will be doing afterwards. Question number 2, second. Which of the following set represent N intersection W? What do we mean by N? The natural numbers continuing. What do we mean by W? Whole numbers 0, 1, 2, 3, so. Now what do you get? The intersection. Intersection means what? Common. So what is common in these two? 1, 1, 2, 2, 3, 3 and so on. So we have 1, 2, 3 and so on. So what kind of set is 1, 2, 3 so on? It's natural numbers, but they have given your 1, 2, 3 dot 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 only. So we'll write down that. Which is 1, 2, 3 dot 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 is, which alternative is it? Second ka A. Question 2, 2, A. Now the next sum based on union and intersection is sum number 4. So we shall do that. Question number 2, the fourth one. T is given the elements 1, 2, 3, 4, 5. M is given the element 3, 4, 7, 8. You have to find T union M. What do we mean by union? Joining. We have to join the two sets, but common we have to write once only. So first underline the common. 3 is common, 4 is common. 3 and 4 is common. That we'll write down only once. Remaining write all the elements 1, 2, 3, 4, 5 of T. And next write all the elements, but the common ones don't write because we have already mentioned it. 7 and 8. 3 and 4 is already written here. 7 and 8. So you get T union M as 1, 2, 3, 4, 5, 7, 8. Which alternative is that? C. So fourth one, the alternative C. Now we go to the seventh sum. Seventh sum is that union. Question number 7. 7. Represent the union of two sets by Venn diagram. Oh, we have to draw Venn diagram. So let us start with the first sum. A is equal to 3, 4, 5, 7. And B is equal to 1, 4, 8. You have to find the union. A union B and then represent it by Venn diagram. Okay, what is common in this A and B? 4. Nothing else. So you join it 3, 4, 5, 7. First I am writing all elements of A. Now I will write the common only ones. B contains the element 1. 4 I am going to write once only. That's common. 8. Now we have to show the Venn diagram. In a Venn diagram, we represent the universal set by a rectangle. We have already studied. and we write down U outside. A and B are two subsets that we show by ovals. A, B. Now, A is 3, 4, 5, 7. But which is common in both? 4 is common in both, now. That will come in this overlap part. Common in both. For A and B, both this 4 will come. So that is why I am writing in this overlap part. Now you write the elements 3, 5, 7. Always you put a dot and write 3, 5, 7. So your A contains of 3, 4, 5, 7. Yes, correct. Now B should contain 1, 4, 8. 4 is written in this overlap part because it was a common element of A and B. What are the remaining ones? 1 and 8. Now you are showing A union B. You have to show it, shade it and show. So this is your A union B. Shade it with a pencil. You have to do it with a pencil. Shaded part is A union B. Is that clear? So second sum for homework. 7th second is for homework. I am doing 7th third one. X is equal to X such that X is a prime number between 80 and 100. Y is equal to Y such that Y is an odd number between 90 and 100. So let us list the set and then we have to find the union. X. X is a prime number between 80 and 100. So which are the prime numbers between 80 and 100? Come on, tell me. First let us try the prime numbers between 80 and 90. Which are the prime numbers? 83, then 89. Then between 90 and 100 only 197. Y. Y is an odd number between 90 and 100. Which are the odd numbers between 90 and 100? There are so many. 91, 93, 95, 97 and 99. Okay. So now let us draw the Venn diagram for this. We represent universal set by a rectangle. Use your ruler and this thing to draw, pencil. Universal set. Now let us draw the two subsets. X, Y. What is common in both? 97. So 97 can be written here in the overlap part which contains for both. Anything else? No. So now here this contains two more, 83 and 89. What about this? 91, 93, 95, 99. Okay, now you have to shade X union Y. So shade it. This is X union Y. So we have shaded X union Y. That's all. Now one last sum is remaining for the union and intersection. That is a 9 sum. If M is any set, then write M union empty set and M intersection empty set. Last sum. After that we have finished with the union and intersection type sums. Then the remaining sums will be done in the next class. 9 sum. If M is any set, then M union empty set. Okay. M union empty set. Let me put M as A and B. Okay. An empty set is empty. When you join them, what do you get? A and B. Isn't it? And A and B is nothing but M. So M union empty set is M. So put some small examples and then it will be clear for you. And what about M intersection empty set? What is common in these two? Nothing. So empty. So M union empty set is M and M intersection empty set is empty. So children, we have completed all union and intersection type sums. The remaining sums will be done in the next class. And please do all the sums done on the board in your notebook, and plus whatever I have told for homework, that you all have to do it in the notebook. Thank you.